Hello class, welcome to subtopic 4.4 in which we're going to discuss the next simple machine which is known as the wheel and axle. La rueda y el eje. Axle is translated as eje into Spanish. And we're going to take a look at the equation that rules the behavior of this machine, and we're going to solve two problems. So what is the wheel and axle? The wheel and axle is this thing, guys. It's this machine. You have already seen it, right? Maybe you haven't used it, or maybe you have used it, you just don't know that you have used it, and I'm going to convince you of that in a moment. So what is the wheel? The wheel is this. The wheel is usually, and by usually I mean 95 or 99% of the time, is it's the big thing, right? It's the circle with the greatest radius. Because here we have another circle, in here, right? So this is not counted as the wheel. This is the axle. Este es el eje, esta es la rueda. Okay, so wheel and axle. And this machine, guys, is also used in order to amplify our force. In this case, when you want to take water out of a well or something, what you do is that you can apply the force right here on the wheel downwards with your hands, and as a consequence of that, you're gonna be able to draw water out of a well or something, or any other type of useful work that you can do with this. And again, it's gonna be this machine is gonna be able to amplify your force, so that maybe if the water, let me draw something here for you. Maybe if the water has a weight of, let's say, 20 newtons, okay, that's the weight of the water. Maybe the force that you need to apply on the wheel is gonna be, well, not maybe, it will be less than the weight of the water. Let's suppose it's half of the weight of the water. So if you did not use this machine, if you did not use it, remember, what is the if you want to raise, let's say you have this bucket over here at ground level. If you want to raise that bucket, which has a weight of 20 newtons, if you want to raise it without any machine, you're going to have to apply the same force as its own weight at a minimum. That is the minimum force that you need to apply in order to raise this bucket that has this weight. But with the usage of this machine, you're gonna need less force, and that's why we use machines, right? Now, what's gonna be the disadvantage of this? Because remember, these things are not magical. What's gonna be the disadvantage? There must be a disadvantage. Well, the disadvantage is that you're gonna have to apply this small force over a longer period of time, or over a longer distance, because you're gonna have to maybe to turn this wheel many times in order to raise the bucket of water just a very short distance. You see what I mean? You're gonna have to turn this, which is gonna take you, probably a lot of time, and this one, the bucket will raise very slowly because the radius of this axle is less. So that's the disadvantage, if we can call it that way. So that's the wheel and axle. Now, this thing has also another configuration. If you notice, guys, we really don't need the whole wheel in order to use this machine. For example, we can have this configuration. Look at this one right here. This thing and this thing are the same, guys. Don't let yourself be confused. The fact that in here we just have one handle, you see in here, one handle, doesn't make it any different than this. You can imagine, like when you move the handle, you can imagine the wheel, right? So basically, what is the advantage of just having the handle instead of the whole wheel? Well, the advantage is that obviously the handle has less mass than the whole wheel, because you can imagine the wheel as having like 6 handles and then the perimeter and so on, and that's gonna add mass you see, to the whole system. And you're gonna need to apply more force in order to also move a greater mass on the wheel. And in here, having less mass, you're gonna have to apply even less force in order to get this thing going. So this is kind of like a simplified version of this machine, but they are in fact the same. They are the same. Now I told you that you had already used this in the case of opening a door. Can you see? Look at this thing, and look at this axle that is very tiny and very hidden in here. This is a wheel and axle, guys. You apply a force in this direction on the knob of the door, and you're gonna rotate the axle basically. And by applying a small force on the wheel, you can apply a very large force on the axle in order to open the door. So you have already used this, you just didn't know it. Where else? In bicycles, okay, the pedals in here, can you see this handle? I mean, the pedal can be thought of as a handle also, and you apply the force on the pedal, which would be the wheel, and you're gonna be rotating this system in here, which is the axle. So you know, it's hidden, guys. It's hidden. Even though you think you haven't used this machine, yes, you have. It's hidden in some places. Okay, so let's take a look at the equation of the wheel and axle. So the wheel and axle consists, like I told you, I'm gonna try to do this very large. So this is the axle, and then it's connected to a wheel or just a handle. I'm gonna just draw the handle case. It's much simpler. So this is the handle, right? And you're gonna rotate this thing. And as a result, the axle is gonna rotate too. Okay, so when we have this machine, guys, we can take a look at the following characteristics. There is a radius from the very beginning of the handle, from this part to this part. That's gonna be the radius of the wheel. Remember, for all practical purposes, this handle is a wheel. When you rotate it, you can imagine that a wheel is being traced in space. So when I say wheel, don't get confused. Okay, this is the same as a wheel. And so from here to here, guys, from this point to this point, that distance is the radius of the wheel. Radius of the wheel. And the axle has its own radius, which is this thing, right? It's the distance from here to here. This distance is the radius of the axle, which is commonly represented by a small case r. So capital R is going to mean the radius of the wheel for us, and small case, lowercase r is the radius of the axle. Okay, and what other things can we find in here? Well, the point in which you apply your force is on this part of the handle, right here. That's where you're going to apply your force. And remember, usually the force that the user of the machine applies is known as the effort, right? So this is the effort force, which is the force that the user applies. And usually this thing is connected to a rope, which is gonna look something like this, right? And then to some sort of bucket. Usually it doesn't have to be like this, but it's usually the case. So you have a rope and then a bucket, and in here, this thing is what you want to raise, right? So this is the weight of this thing, guys. The weight of this thing is known as the load. Okay, so that's it, guys. Those are all the characteristics of this machine that we care about. Load, force. We have a big radius, the radius of the wheel. We have a small radius, the radius of the axle. We have the effort force that the user applies, and we have the load force, which is going to be basically the output force that the machine will produce when you input this force as a user. Okay, and then the equation of the wheel and axle, guys, is this. It's going to look like this. The equation is going to be the effort force times the big radius, or the radius of the wheel, is going to be equal to the load force, which is the weight that you want to raise, and times the small radius of the axle. So this is how it works, guys. This is the equation of the wheel and axle. And again, one more time, try to notice how it's pretty much the same as in the previous cases for the lever and for the inclined plane. If you remember, the equations for the lever and for the inclined plane were pretty much the same. For the lever, it was the effort force times the length of the lever, right? I'm sorry, times the load arm. I'm sorry, times the times the effort arm. The effort times the effort arm, which is a distance, right? Equals the load times the load arm. So it's force times distance equals some force times some distance. For the inclined plane, what was it? It was the force that we apply over the plane times the length of the plane equals the weight of the object that you want to raise times the height of the inclined plane. So once again, look, it's force times some distance equals some force times some distance. And here is the same. Some force times some distance, which is this distance, right, equals another force times another distance. You see, so it's pretty much the same equation, guys. It's basically different versions of the same physical concept. So this is the equation. Let's write it down and let's put it to use. So let's solve these two problems, guys. Let me erase all of this. So the problem 1 says, consider a wheel and axle in which the radius of the wheel is 0.5 meters and the radius of the axle is 0.2 meters. So let's draw that right away. We have the wheel in here, represented by the handle. Maybe I can draw that better. There you go. And we have the axle, and they are giving us the radii of both of them. So this radius, the radius of the wheel is 0.5 meters, and the radius of the axle, which is this, is 0.2 meters. Okay. And then let's continue. This machine is used to take water out of a well. Like I told you, this thing is usually attached to a rope, or well, but the other way around. A rope is attached to the axle, and then it's attached to a bucket or something, and we can use this machine to take water out of a well. How much effort force do you need to apply on the wheel? How much effort force? How much force do I need to apply on this wheel, guys? How much effort? In order to take out 10 kilograms of water, if there is water in here, and if I know that there are 10 kilograms of water, then how much effort do I need to apply to lift this much water? Okay, let's see. What is the equation that rules the behavior of this machine? The equation is, like I told you, the effort, which is the force that the user applies, times the radius of the wheel. That's going to be equal to the load force, which is the weight of the object that you want to lift, times the radius of the axle. So this is it. Now, do we have E? No, we don't. So let's just keep it as a variable. Do we have capital R? Yes, 0.5 meters. Do we have the load force? You may think that it's 10 kilograms, but no, this is mass. This is mass, right? And this thing represents a force. So you need to get the weight of the water. The weight. You don't want the mass, you want the weight. And weight equals mass times gravity. So therefore, the weight is going to be 10 kilograms times 9.8 meters per second squared. And so the weight is going to be 98 newtons. So that's it. That's the load, guys. That's the load. That's the load that you want to lift. 98 newtons and small r, which is 0.2 meters. That's it, guys. You see, we have come up with an equation with only one variable, which is the effort. And let's just isolate the effort. And let's just calculate all of this. Let's do all of this arithmetic. Let's use a calculator. And you're gonna get 39.2 newtons. And this would be the answer. So how much effort force do you need to apply? How much force does the user need to apply here in order to raise 98 newtons of water? The user needs 39.2 newtons of force. So like I told you guys, this machine once again allows you to perform a task which is raising 98 newtons by applying a much smaller force than necessary. If you did not have this machine, you would have to apply the same force as the weight of the water in order to lift it. But now, since you have this machine and it offers some mechanical advantage, then you only need to apply this much force over a longer distance, right? Because the radius of the wheel is greater than the radius of the axle, so you're gonna have to do this over and over and over and over again. But at least you can do so by applying a small force. So that's how it works. And next and final example, we have a screwdriver. What is a screwdriver? It's un desarmador. They look more or less like this. Okay, and it has a handle. This is the handle, right? That is 4 centimeters in diameter. So this is 4 centimeters in diameter, and a shaft of 0.75 centimeters in diameter. This is the shaft, guys. This little, let's call it stick, maybe. This is the shaft. So the diameter of this thing is 0.75 centimeters in diameter from here to here. How much force would you need to apply in order to have a load force of 50 newtons? Okay, so how does the screwdriver works, guys? How does it work? Basically, what you do is you apply a force on the handle, right? With your hands, you're gonna grab this thing and apply a force in a circular way, right? And this is your effort, and that effort is gonna be transmitted along this shaft, and it's gonna be applied over here when you have, I don't know, some sort of screw or something. I mean, that's why it's called a screwdriver, right? You're gonna be applying that force on the screw, by applying the effort on the handle. Okay, so in here it's gonna be the load force right at this point. That's where the load force is gonna come out of this machine. Okay, so that's the whole configuration. Now, does this machine resemble a wheel and axle? Yes, this is the wheel. Can you see? And this thing is the axle. That's it, guys. So therefore, since this is a wheel and axle, we can apply the equation of the wheel and axle. The effort applied by the user times the radius of the wheel is equal to the load force times the radius of the axle. So let's see. Do I have the effort? No. That's what I'm trying to find out, right? Do I know the radius of the wheel? Yes. And don't make the mistake of putting this in here. It's not 4 centimeters. It's gonna be 2 centimeters. Why? Because this is the diameter, guys. This is the diameter of the wheel, and this is the radius of the wheel. So it's gonna be half of this. The load. Do I know the load? This force that's gonna come out of here? Yes, because they tell me that I want to have a load force of 50 newtons. So there's gonna come out 50 newtons out of that place, out of this place of contact. And the radius of the axle, once again, it's not this value, guys. It's half of this value, because this is the diameter of this axle. So let's divide 0.75 over 2, and you'll get 0.375 centimeters. So that's it. Once again, guys, you have an equation with just one variable, and then we just isolate it and do the arithmetic. That's it. So let's calculate that value, and I'm getting 9.375 newtons. So once again, the effort that the user needs to apply in order to come up with this much force out of this machine, in order to take out a screw or something, then the force is actually much less than the load force. In other words, the force that you input in this part of the machine, the force that you input is going to be transformed into a much greater force at the output of the machine. You see, that's basically why we use machines. Okay, guys, so that's it for the wheel and axle. Let me go back with you. Thank you.